Hello everyone and welcome back to my channel. Today we're going to be solving IMO 2025 problems 1, 2, and 3. So for problem 1, a line is called good if it isn't parallel to any of these following. And we've got n is a given integer and we need to determine all the non-negative integers k such that there exist n lines in the plane satisfying both of these following. So let's just get in. We have a bounded area of integers a, b, such that a plus b is less than or equal to n plus 1. And this point is need to be on at least one of the lines, and exactly k of these n need to be sunny. Now, it's kind of obvious for n equals 3. I claim k equals 0, 1, and 3 are the only answers because, well, 0 obviously works, 3 obviously works too, and 1 works because you can just take two lines and then the third one just a random line. Okay, now why doesn't 2 work? Well, 2 doesn't work because if we get either one of these lines, like if we get this line, then these 3 points, if we need to cover 3 points with 2 lines, 2 of them need to be collinear, and if you don't get any of these lines at all, then all three of them will be sunny, and that's the contradiction because we needed only 2 to be sunny. Now, suppose we know for n minus 1 and we're going for n. Now look at this. I'll prove that at least one of either this, or this line needs to be there. Suppose not. Then we have n lines. We need to cover these 3n minus 3 points, 3 times n minus 1 points that are on the edges. But if we now know 3 of them are collinear, then 2n is less than this, and 2n is the most amount of points that n lines can cover, because no 3 of them are collinear. This means that this is a contradiction, and if one of these lines is there, we just get a configuration for n minus 1. So this is the answer for all n. Now moving on to the second problem. We're giving two circles with centers m and n. They intersect at a and b, and the line mn intersects the first circle at c and the second circle at d. Now P is the center of the circle CAD, and E and F are the intersections of AP with the first circle and the second circle respectively. We need to prove, and H is the orthocenter of the triangle MPN, and we need to prove that the line from H parallel to AP is tangent to the circle BEF. Now, here we go. So first, let's call this alpha, let's call this beta. So what do we know about P? We know APN is alpha 2. Why do we know that? Because P is the center of CAD, and AD, arc AD is alpha, which means the arc AD is 2 alpha, which means that APN is alpha. What that gives us is this angle is 90 minus alpha minus beta, because the entire angle is 90 minus alpha, and this will be 90 minus alpha minus beta. So AP is the bisector, so this is 90 minus alpha minus beta, this is 90 minus alpha minus beta, and so is this and this. Well, where G, I've picked G to be the intersection of EM and NF. Now, look at this. F and M, what does F and M equal? Well, F and A is 180 minus 2 alpha minus 2 beta, because these two are equal and they're equal to 90 minus alpha minus beta. So F and M is 2 alpha plus 2 beta. So if this is 2 beta, then this is 2 alpha and this is 2 beta. So this just means AMGN is a parallelogram. It just makes MBGN be a cyclic trapezoid, because B is the reflection of A over Mn. Now what do we get from this? We need to prove that EBFG is cyclic, so I'll prove EBG is equal to 90 minus alpha minus beta. So what does MBE equal? Well, MBE is equal to well, let's just MBA. What is BAE? What does BAE equal? BAE equal MAE minus MAB, which is alpha minus beta, because MAE is 90 minus alpha minus beta, and MAB is 90 minus 2 alpha. So BME will be 2 times alpha minus beta, and MBE will be 90 plus alpha minus beta from that, and that just means EBG will be 90 minus alpha minus beta, because no, this will be 90 minus alpha plus beta, and this will be 90 minus alpha minus beta, because in total it needs to be 180 minus 2 alpha because of the cyclicity. So we've just proved it's cyclic. Now we look at H. The angle HNM equals 1. The angle HNM equals 90 minus the angle PMN, which is just the orthocenter property because of this, right? And PMN is just, what does PMN equal? This equals 90 plus alpha. Why does it equal 90 plus alpha? Because this is 90 minus alpha. This is 2 alpha, and my bad, it equals 90 minus alpha. Now 90 minus 90 minus alpha, because PMN is 90 minus alpha, so this is 90 minus 90 minus alpha, or just alpha. So this thing is alpha, and then which means this thing will be beta. So H will be the incenter in MGN. This means HGM is 90 minus alpha minus beta, but it just means HG makes the same angle with the line AME as AP. So HG is parallel to AP, but also with that we get that HG is touching the circle BEF, because HGE will equal EFG. Now for this third problem, we're given a function. It's called good if FA divides B to the A minus FB to the FA for all positive integers A and B, and we need to determine the smallest constant such that Fn is less than or equal to Cn for all good functions f and all positive integers n. Now, what do we get from here? Fa divides A to the A minus Fa to the Fa. This just means Fa divides A to the A. Okay, so now for a prime p, we get Fp is p to the alpha for some alpha. And now suppose for infinitely many primes p divides f of p. Well, this just means that p divides f of p divides b to the p minus f of b to the f of p. This just means b to the p is congruent to b mod p, and this is congruent to fp mod p, because fp is divisible by p. So this just means p divides b minus f of p. Well, if infinitely many primes suffices this just means that p divides b minus f of b for all b. And this just means that either b equals f of b, or for primes, some primes above m, for some primes above m, some constant m, f of p equals 1. So this is a one solution, and the other solution is that, no, the other case is for some p greater than m, f of p is equal to 1. Okay, now pick such prime p and any a. We get f of a divides p to the a minus 1. What does this mean? Well, take some prime q dividing f of a. Well, we get q divides p to the a minus 1 for all infinitely large p, but with Dirichlet's theorem, we can just take the p such that this doesn't hold. Okay, so it will just give us that f this what this just means is that if a is odd, then f of a equals 1. Well, the thing is, if we just pick a be even here, and if f of a has any other divisor uh, other than 2, or if f a isn't a power of 2, then we can just do the same thing and it will uh, be a contradiction. So this just means if a is a power of 2 if a is even. Well, then we can just follow by LTE. So we take a b such that b is odd, and we get f of a divides b to the a minus 1. So yeah, we can't have some odd number dividing f of a, because if it does, then we just let b equal that odd number, and then this will be a contradiction. So fa is a power of 2, so v2 of fa is less than or equal to v2 of a plus 2. If we pick b such that b minus v2 of b minus 1 is 1 and v2 of b plus 1 is 2. Both of them can't be 1 because b is either congruent to 1 mod 4 or 3 mod 4. So this is what we'll get, and this just means that f of a is less than or equal to 4a because f of a is a power of 2. And because it's a power of 2, it will not have any other divisors. So this will hold for every number a. So just this leads us to get the answer c equals 4. And